In this video, I'm going to introduce you to this new model called as MoMo 70 billion. Before I do that, I just wanted to touch very quickly on this company which is behind this model, and it is spelled as MOREH or More, I guess. This company seems very interesting to me because what they are doing it, they are providing a full stack infrastructure, hardware plus software in order to implement your AI models and applications. And this sounds really good. I'll drop the link to the website in video's description, but just to give you a very quick idea, with this More AI, you can train and deploy any multi-billion or multi-trillion parameter model, and this is the first any platform I have seen so far. And you can also program anything you need for pre-training, fine-tuning, compression, and serving the model. Plus, you can scale to thousands of GPUs by automatic parallelization and optimization. You can also virtualize all GPUs in a cluster for higher utilization and failover. This is the first. I have not seen much failover or switchover in terms of these hyperscaler cluster as of yet. You can also decouple AI infrastructure from the specific hardware vendor, which is amazing. And of course, you can use PyTorch, you can use TensorFlow, you can use Triton inference servers. Whatever your need is, there is a highly likelihood you can use it easily. So they are providing an end-to-end platform which is called as MoAI platform, as you can see on this website. And there are a lot of other information which you can read through their website. Seems very interesting to me because not only you can have a GPU system, runtimes, compilers, frameworks, cloud platforms, and you can deploy the whole AI stack by including application, foundation models, software, hardware, whatever you need. Okay, now the main idea behind this video is to show you how you can install their model MoMo 70 billion LoRa, which is quite an interesting model within its own self. This MoMo 70 billion is trained via SFT or supervised fine-tuning using LoRa. Supervised fine-tuning is the process of fine-tuning all models parameters on supervised data of inputs and outputs. This SFT teaches the model how to follow user specified instructions. It is typically done after model pre-training, and it uses LoRa for this. So MoMo uses LoRa for SFT, and LoRa stands for low rank adaptation. It is an AI training technique that helps to fine tune models. It serves as a link between large files and written inversions. With LoRa, you have a well balanced combination of files in manageable sizes and significant model training power. And there is a lot to it, and I have done few videos where I explain in very simple words what LoRa is. Just search with LoRa on the channel and you should find something. Coming back to this MoMo 70 billion parameter model, this is using Qwen 72 billion as its base model, and they haven't exploited any weight merge, but they have just realigned the trained weights for the Hugging Face. Of course, this model is trained using this MoAI platform which I showed you just a while ago, and it really simplifies the training of large scale models, and it seems it is using AMD's MI250 GPU behind the scene. So for datasets, it is using SlimOrca from OpenOrca, and that's it. That is amazing, and I'm very keen to see its performance as how it works. I'll be using Block's quantized version to locally install this MoMo 70 billion because I don't have that much hardware to get it installed in full blown version. The tool which I'm going to use for this video is called as LM Studio. I already have installed it. If you don't know how to do it, I have few videos where I explain it in detail. Just search with MoMo on the first page, home page after launching LM Studio, and you can see Block has beautifully done its quantized version. I have already downloaded it, as you can see, and even the lowest quantization has around 30 gig. So I'm not sure if it even work on my laptop which has just one GPU, but let me try it out. So you can see here I have already downloaded it, and click on these three dots. Let's select the model. So if I won't be able if it won't fit on my system, it will crash here and I won't be able to show you the demo, but let's see. I'm doing it in real time, so bear with me and let's see if it works or not. If it will crash, if it won't. And on the top left you can see the resource usage. So far it has used close to 25 gig of memory, sizing up, going up, close to 30 GB now. Okay, because I just have 30 GB, so I think should be good. Okay, let's do some inference. Let's ask a question. Which one came first, egg or chicken? Let's see what it responds with. Let's wait for it to come back. So you can see that the model is too heavy, but look at the response it has pasted so far. If you are following my videos, I have asked this question from a lot of other LLMs and I have never received such response. So just look at response. It says, in general terms, the egg came before the chicken. However, it depends on what you mean by chicken and egg. If you mean a hen's egg, then yes, the egg came before the chicken. Okay, makes sense. But if you mean an ostrich egg, now this is very, very interesting because look at my question. I have asked it which one came first, egg or chicken. So what it is implying here, the model, is that I didn't mention whether I'm talking about chicken's egg or just a generic egg, and that is what it is referring to. That if you mean an ostrich egg here or something like that, then no, chicken came first because there were already hens and roosters running around before any ostrich existed. So this is amazing. And now I'm not sure if this is a correct statement that ostrich was not there. So it says the second paragraph response is a bit confusing. Okay, so I'll just stop generating it. I think this is just a very philosophical sort of LLM. Anyway, let's ask it one more question. So this is the question, which is sort of a reasoning question. In this, I'm asking it: three friends, Alice, Bob, and Chris, chat at a bar. Alice leaves for the restroom. Meanwhile, Bob, wanting to play a prank on Alice, takes her cell phone from her purse and puts it in his bag. Alice comes back and wants to check on her messages. Where does she look for her phone? So what in this response, what I'm trying to do, I'm just trying to see how the LLM does the reasoning. So let's see. Unfortunately, the thing is that it's a very heavy model and you can see that my system is struggling. So I'll just pause the video and then once the response is there or any sort of response is there, I'll just resume it. So it seems that model is quite complex because if you look at the response which it is giving, especially for the second one, it is trying to reason, but I think it is talking to itself where it is saying that, okay, first and I think it is going with response that first word is wrong, second word is fine, and then it is also picking its own mistake, I guess, because it says the second paragraph also needs some work. So maybe it reasons and then it produces the answer. So as my system is too slow, I'm not going to print the whole thing, but I believe maybe it would be good to have the answer straight away and then it can tell us its reasoning. Let me ask it one final question and I'll just also try to put it in the prompt. Just give me response in one line, let's say. Hopefully it will be quick this time. Because you can see at the top my CPU is like too high. Memory is fine, so let's see what happens here. And remember, this is a quantized version. This is not a full-blown version, so we can ignore these things, the minor things or minor mistakes in the responses. So model has conveniently ignored my instruction for a one-liner response, but the response is quite good. And it is different too. It says that you could wear a shirt that says I hate you and something like that. Or you could have an ugly face tattooed. That would definitely make people not want to talk with you at all. And then So look at this response. But seriously, if there are other options beside these two things, and there probably are, then maybe try being really annoying, like talking too lightly, loudly, or this. So this is actually quite interesting because model doesn't hasn't given me the response with authority. It is having some sort of self doubts, so which is good. And if you look at all of the responses, the self doubt is quite evident, and I think this is what we like about we should uh, be wanting from our models because, but this is more like artificial general intelligence where because humans always have some self doubt lurking at the back of mind. So this is what this model is also displaying, which is quite interesting. Anyway, that's it, guys. Let me know your thoughts on it. I'm quite impressed by the model, and it's a huge model. Even the contest version is giving out some very good responses. And the main takeaway for me was this self doubt in the responses. Anyway, that's it. Let me know your thoughts, and if you like the content, please consider subscribing to the channel. And if you're already subscribed, please share it among your network because that helps. Thanks a lot.